edge compute at Ampere. And we have Gordan Markus, so strategic alliance manager for silicon partners. And yes, so the topic today, why we are getting together, is this beauty here, right? So this is the star. So I hold it into the camera. Can you see it? So it's a very nice piece of technology. So we are talking here about the latest ARM technology, brought into a very interesting embedded format. So it's a computer module. So, and we're more than happy to have you, Joe, here on the stage, and you, Gordon. So we are talking today a bit about AI and use cases, how to leverage this kind of technology to a broad range of applications. And we're not just talking about hardware, we're talking about software too. Software, with software I mean firmware and operating systems. This goes more towards your value proposition. So, and yeah, we are talking about Canonical Ubuntu certified Ampere Ultra products. And yeah, we prepared a couple of slides today. We are going to share some interesting use cases. And yeah, let's start with the first slide. So, Joe, over to you.
Hi, everyone, and thanks a lot, Richard, for having us here at the booth today. It's really amazing. So let me just scoop right in so folks can see me the best way. And hello, everyone here. I hope you're having a great show so far. It hasn't been long. It's just started a couple of moments ago. But anyways, I'm working for a company called Canonical. And you might know Canonical as the maker of Ubuntu. And what is really unique at Canonical is that we're actually doing more than Ubuntu just now. And we really like to say that we're the company that's powering open source as well as AI. Because today, the majority of the AI is powered by open source. And what we really strive to do is deliver open source at scale that's long-term supported, security maintained, that can reach a broad audience, all the way from folks at the universities to professionals in the factories who are developing and deploying their inferencing models in robots that are painting their cars and beyond that. And I mean, once again, thanks a lot for being here, Richard and Joe. I think it's amazing. So yeah, I'm going to hand it over to Joe about the story that we did together between Ubuntu, or actually, I can also take this one, was what we did together between the three companies, right? What we really want to say here is that 1 + 1 + 1 is not 3, it's 10 in reality. What we really did together is, with the module that you were showing, Richard, which is highly capable for multiple different purposes that Joe is going to introduce later on. But what we did together essentially is we made sure that this product is Ubuntu certified. What does that actually mean? And that's a really good question that Richard asked us before having this discussion. And what it means is that what we did in Canonical is take the product, optimize it together with Ampere for their SoC. We put it in our lab. We did the quality assurance and testing for reliability. We stabilized the product, and we're going to keep those boards as well as other modules tested for 10 years for the duration of our long-term supported release. Every single time there's a security patch for the software, we're going to regress test it on that platform. Right? So this is all done on real hardware in our laboratories. So essentially, folks that are using your module together with Ubuntu, as long as our relationship is as strong as it is, continuously with the new products we're going to come to market, they're going to be behind. There's three companies that are supporting it for the full life cycle, meaning 10 plus years. So I think this is a really amazing story that we bring as bring the value proposition to our partners, essentially. And I'm going to hand it over to Joe now.
Hi. So with Ampere, what we do is we give you a large number of very energy efficient cores. So it's ideal for our processors were designed for these virtualized, containerized workloads. So with ADLINK, we take the same silicon that's running Google Cloud, Azure Cloud, Oracle Cloud, Supermicro telco servers, and HPE data center servers, and we put it in embedded systems, okay? And because it's so efficient, think about getting 3 times the performance for the same thermal or TDP budget, okay? Think about being able to do the same workload you do today, but with 1/3 the heat or 1/3 the power use, okay? And for the AI inference, and this is a really exciting thing for the embedded systems with all the computer vision and the other kinds of, edge AI ML inference use cases, is with our work with Canonical and ADLINK. So think about getting 4 times as many cameras, like with the YOLO V8 inference, for example, 4 times as many cameras per watt compared to like a Xeon D. Okay, so being able to have this very dense, large number of cores doing these things, and for some workloads like the Whisper, which pairs really nicely with the video. So Whisper does your voice to text. So now not only can you have all these live video feeds, but you can get live transcription of what everyone is saying in the videos. You want to talk about the lifecycle?
Sure, and I think that when we look at all the possible use cases that you might have with this platform, that's really nice. And as Joe said, it's really a platform that is made for cloud-native processing as well, and you can bring that beauty to the edge, right? And if you look at the whole AI lifecycle, what you usually do is you start with your development, right? And this is at the point in time when you would attach a GPU, you would train your models, you would use frameworks like TensorFlow, PyTorch, and you would do that through Ubuntu, naturally. And when you're actually ready to get into prototyping phase, you would start to deploy it onto, let's say, a modular device at the edge, used for inferencing. Then you would probably remove the GPU in this use case that Joe actually described right now. Then going further, with Canonical, what we designed is also a way how to serve the models at the edge through open source frameworks, as well as use our software as a service offering, where you can drop models via our store as well. So essentially, we really want to cover the full life cycle and making sure that this is stable. Right? Once again, getting back to the story of the certification, we want to make sure that this is stable for 10 plus years. So if you deploy something in your factory and it's continuously connected, we want to make sure it's going to last there for 10 years. You're going to get security patches, and all the malicious actors are going to be stopped.
Spend it comment. Hey, so we've heard super interesting topics like being super energy efficient,
Yes.
right? I mean, this is super essential because more and more energy consumption is driving the total cost of ownership as well. So this is super important. Then it's very inspiring to see to use this kind of technology in AI use cases, what one maybe not traditionally associate with CPUs, right?
Yeah.
So, but it's super interesting, this aspect. And secondly, we in the embedded space, we really need longevity, right? And we are talking here about a one-stop solution from software to hardware to system integration. We're going to see this in a couple of slides, which kind of solutions we can offer. And as I said, longevity is super important. We have a good solution here. Super.
And one of the things that I love that, so Gordan talked about kind of that software life cycle, but from a hardware side, you look at what ADLINK has done, that going from development to prototyping a product to deploying it. So having the Ampere Ultra Dev Platform developer workstation by ADLINK to develop and test the software and develop your models, being able to prototype new products using the COM-HPC and carrier, and then being able to deploy it. So, from both software and hardware, together we have you covered. And to show you an example of this is Alephia AI. So Alephia AI does medical imaging AI, so precision medicine, okay? And so they've worked with ADLINK, with Canonical, with Ampere to develop these medical imaging applications, taking the best of the available algorithms and ML models from universities and other places and integrating it into a cohesive user experience, being able to prototype a new product and then actually being able to deploy it. And so I'd like Camilo Buscaron. He's the co-founder CEO of Alephia AI, and he can tell you about that as well.
Thank you, Joe. Thank you, Richard. At Alephia, we're building a precision medicine integrated platform to accelerate some of the most difficult and challenging workloads and workflows in scientific discovery, medicine, precision medicine. A lot of our use cases are around neurology research, digital pathology. Thanks to our friends at ADLINK and Ampere, we were able to go from nothing to deploying a prototype at one of our main customers in less than 6 months. This is the Stanford Medical School Department of Neurology and Neurological Sciences, and what they're doing at Stanford and the Acacia Clinics is they're pioneering a fMRI guided transcranial magnetic stimulation therapy. In this case, Acacia has to pre-process large data sets that come from fMRI machines, and today that they're only able to do 1 or 2 at a time, and it takes about 24 hours to process with the current state of the art applications. With Ampere Compute, what we've been able to do is being able to scale out the amount of fMRI pre-processes we can do to up to 100 at a time in less than 5 hours, and that has led Acacia to improve the therapy to levels not seen in the industry before, which is nearly now sort of the best treatment you can find for depression, which is a globally debilitating disease. So we're very grateful for our friends at Canonical and Ampere and ADLINK. So thank you. A little bit back to you.
Yeah, thanks, man. Thank you. Thank you very much. Hey, as you can see, I mean, from the prototyping within 6 months, how is this possible, right? It requires somehow a go-to-market solution, which is predefined, and COM-HPC is a very good option to do so. Meaning that the whole work of hardware and software integration is done on silicon level, on module level already, and the customer can finally focus on the carrier board solution, which is close and which is then reflecting the applications requirements. And there's no faster way to deploy technology in such kind of inspiring applications, which at the end helps people, right? So we're really, yeah, it's a nice contribution. Super. Hey, Joe, I'm wondering what other kind of AI use cases you see at the moment where this kind of piece of technology can make the difference.
Sure. So we're seeing things around computer vision is obviously the obvious one, right? Anytime you talk about edge. We're also involved a lot in various like 5G communications kinds of projects, and they like to do some introspection analytics and look for patterns or deviations from patterns. So it's a great fit for that. And various other kinds of sensor machinery health. We're involved in a thing for machinery health for ships, for a large fleet of ships, and also doing some DevOps security applications as well with this. So it's very exciting.
And especially when one is looking at a battery-powered application at the edge, I could imagine that this really makes the difference, right? Since we've learned that it works with a fraction of electrical energy, which delivers the same performance as traditional, let's say, x86-based technology.
Yeah.
So, so battery-powered application, do you see there's well use cases?
For which?
In general, embedded edge AI use cases which are battery powered. So
yeah, it's anything that is battery powered, whether it's EV vehicles or base stations or anything like that. Being able to do more work using less power helps a great deal. So like our processor is involved and used in some autonomous driving programs. So EV autonomous robotaxis and vehicles and things, and it allows them to do a great deal of compute, and it actually translates into the vehicles can drive further because the compute is using less power.
Super. And I personally, so I'm a techie as well, right? So I worked as a field application engineer and so on and so forth. I tried it myself. So I took the module, I put it on the carrier, and I simply installed Ubuntu, and it simply works. It's really magic. That's super great. I think this product, it doesn't feel traditionally like ARM, you know? And with ARM, I mean, it feels like ARM that's sometimes slow in terms of image deployment, and you need to build your images and so on and so forth. It really felt x86. So thanks to Ubuntu, right? Because you did all the job up front, right?
So, and
you first?
Maybe I can make a comment on that. I mean, that's thanks also to the great partnership we have with MP. So we exchange a lot of information. Our engineering teams work closely, right? So to make sure that on the firmware level, as well as in the operating system level, things are completely stable. Right? And then we work on the specific module to certify it. So that story is really end-to-end time. So we want to make sure that our partners have that longevity story covered and the ease of use, because that's the entry point, especially today with AI. AI is immensely complex. The amount of software and knowledge you need to have, the entry barrier should be lower. And what we see from Canonical side is really that Ubuntu is that unique entry point where everybody that wants to do AI at the edge or in the cloud, they go to Ubuntu and they consume open source through Ubuntu. And that's why I think that the relationship between Ampere and Canonical is also great, because we have these use cases in the cloud as well as at the edge.
Perfect. Maybe we can step one slide back. This one. It's about prototyping. And I think this slide very nicely explains how to getting started with this kind of technology. So you can either take the system, which is a kind of tower build when you're focusing on software and your specific AI workloads. You can stuff this system with, for instance, additional accelerator cards, like graphic cards, and so on and so forth. So it's very nice and showcased here on our live on our booth. It's working there. I invite everybody to join our booth, and then we can have a deep dive later, of course.
And Jeff Geerling has done a frankly brilliant set of videos about the developer platform and all kinds of crazy science projects and things, running the world's most powerful, what he calls the world's most powerful ARM desktop. And he refers to it as like the Mac Pro Apple should have made.
Super. And secondly, next to the overall system, we have the computer on module with the underlying carrier board and a bunch of accessories. That's super nice for prototyping, right? You can simply jumpstart and put this into your application. You can just give it a try. So meaning from the integration point of view, you can do proof of concepts very fast and simply by taking these ready-to-use carrier boards. And what is great with ADLINK solutions is we make all those reference carrier data available to our clients, right? So meaning you can copy and paste a lot. You could imagine this product is super complex and carrier boards are sometimes super complex too. You have high-speed Ethernet interfaces, distortion on the line here. And you have high-speed PCIe as well. We all bring this reliably down to the carrier, and the customer can add their accessory and focus on their mission to bring value while concentrating on their application. And and of course, the next step is that customers are starting to design their own carrier board. So with our local support teams in Europe, in Americas, in Asia, everywhere. So local for local, this is our support approach. And last but not least, what brings it to the point, right? It's super interesting to see that ARM technology allows us to define the most powerful computer module which is available to the market at the moment. And next to that, it is the most energy efficient computer module to the market right now. And isn't it super innovative? So it's a super great product. We would love to furthermore discuss your application, your project. Feel free to step by at our booth. We are on hall number 3, stand 147. You're more than warmly welcome to step by at our booth. And of course, Ampere, you have your booth here as well.
Yes, so we're hall 5, stand 132. So we're in between Intel and AMD, so you can't get from Intel to AMD without going through Ampere.
Okay, that's great.
And then
Canonical booth is in hall 4, but I have to really check what's the number. I know how to get there. It's still the first day of the show, folks. So bear with us.
Great. All right. See you next time. Ciao.